Our next topic is refracting type of telescope. Telescopes are optical instruments to see long distance objects. So, to see the long distance objects, the primary requirement would be to collect more of the light. The light that is coming from that objects will be large. For that, what we do, we have the objective of the telescope as the larger one with large focal length. Now we are discussing about the telescope in which the final image is formed at the distance of distinct vision. Let us see how to draw the diagram of this. It is very easy. This is the optic center of the telescope, objective lens. Now what we do is that since the rays are coming from infinite, they will be parallel rays. So the parallel that is coming at the optic center will go undeflected, and the second ray that is parallel to this will cut this ray at the focus of the objective lens. So this distance will be the focal length of the objective lens. We can write it as f. Now, since the final image is formed at the least distance of distinct vision, in that case, the object for the eyepiece should be within its focal length. So, if I put it like this is the focal length of the eyepiece, this is FE, and this distance will be UE, distance of the object from the eyepiece. One ray will go parallel, that will pass through the focus of the eyepiece, and the ray will go from the optic center of the eyepiece, and on increasing this, extrapolating this, we get a point here. This is the final image that is obtained here. Let this image is A dash B dash. This is A double dash B double dash. The optic center of eyepiece is O dash. Then the angle formed by the image at the eyepiece will be beta, and the angle formed by the object will be alpha. This is alpha, actually this one is alpha. This is vertically opposite angles. Now we are interested in getting the value of magnification. Now the magnification M. When we are talking about magnification, it is just the angular magnification, and M will be equal to tangent of beta upon tangent of alpha. Tangent beta, that is the angle formed by the image at the eye, to the angle formed by the object at the eye. That is alpha. Now, what is the value of tangent beta? If I write it here, M. Tangent beta is perpendicular upon base. Perpendicular is A dash B dash, and the base is B dash O dash. Again, tangent alpha. For tangent alpha, we take this angle alpha. It is again equal to A dash B dash upon O B dash. It is A dash B dash upon O B dash. Finally, what we get? We get here as O B dash upon B dash O dash. Now, O B dash is basically the focal length of the objective lens. It is FO. And what is B dash O dash? B dash O dash is the distance of the object from the eyepiece. It is UE, and since it is against the direction of incoming ray, it will be minus UE. So the magnification M will be FO upon UE. Now we are not knowing what is the value of UE in the case of telescope, so we have to get the value of UE by other means in the terms of focal length and the least distance of distinct vision. Now the final image is formed at the least distance of distinct vision at distance D from the eyepiece. Let us find the value of 1 upon UE. For that, we know the lens equation 1 upon F is equal to 1 upon V minus 1 upon U. In the case of eyepiece, if we put the values of these, this will be equal to 1 upon Fe, this will be equal to 1 upon V. What is V? V is the distance, least distance of district vision. Again the distance is taken against the direction of the incoming ray, so this will be negative. So this will be minus D minus 1 upon U. Again U is taken against the direction of incoming rays, therefore it will be minus UE, and if we solve it we get 1 upon minus D plus 1 upon UE. From here we can get the value of 1 upon UE as 1 upon Fe plus 1 upon D. Okay, what we do is that we take 1 upon Fe as common from here, we get 1 plus Fe upon D. 1 upon D. Now what we do? To get the final expression, we put the value of 1 upon UE from here in this equation. Because Fe is known to us, it will be given in the question paper. D is well known to us, so UE was not known to us, where the image is forming. So we get the value of M as minus Fo upon this Fe in bracket 1 plus Fe upon D. Now, if you want to have larger magnification, what we do? As I said earlier, the focal length of the objective lens should be larger and the eyepiece should be smaller. Thank you.